Good morning, everyone. Hope all is well. Hope everyone's doing all right. We are, it's 9:33. I'm going to give it a few more seconds to see if anybody else is going to tune in, and then we'll get started. All right. So hope everything's all right. Hope everybody's doing well. Last class we started, we did 11.1 and then we started 11.2 and we left off here at factorial notation. So we'll be pick up right here, close out 11.2, then do 11.3. um, short sections. So when we talk about factorial notation, that's this exclamation point and explanation point in mathematics, means that you will take the number that's in front of it, count down by one, all the way down to one, and multiply those numbers together. So we have a small example here of 4 factorial. That will be 4 times 3 times 2 times 1, which would be 24. So if I had an even larger number, let's say if I had 100 factorial, that would be 100 times 99 times 98 times 97 times 96, all the way down to 1, and you multiply all those numbers together. All right. So 1 factorial is equal to 1, but also 0 factorial is equal to 1. There is a proof for it, but I'm pretty sure you guys aren't interested in that. But just know that 1 factorial is equal to 1, and 0 factorial is equal to 1. All right. So let's talk about how we would evaluate these. So talk about the long way of doing it and then the short way. So let's say if I had 8 factorial over 5 factorial. Now the long way of evaluating this type of problem is writing out all of the numbers and then canceling out what's in common with the top and bottom. So if I have 8 factorial, that's 8, 7, 6, 5, 4, 3, 2, 1. 5 factorial is 5, 4, 3, 2, 1. Then we recognize that 5, 4, 3, 2, 1 is in common with the top and bottom, cancel them out. You're left with 8 times 7 times 6, which would be 336. Now, you don't want to have to lean on that process, especially if you're talking about writing it out, because let's say if you had 100 factorial, you don't want to have to write out 100 times 99 times 98 times 97 all the way down to 1. So, and now you can use a calculator, I'm not taking that away from you, but we're talking about the mechanics behind it. And let's say if your calculator wasn't working, right? So, um, this is the short way of doing it. We recognize that in 8 factorial is 5, 4, 3, 2, 1, which is 5 factorial. And that's what we had in our denominator. So we just write all the way down to just the 5 factorial and allow that to cancel with what's in the denominator. And that leaves us with 876 once again, which is 336 when you multiply them out. Questions on that? All right. So if I have 100 factorial over 98 factorial, I would just count down to 98 because that's what's in our denominator as a factorial. Those cancel, leaving me with just 100 times 99, and that would be 9,900. One more. 26 factorial over 21 factorial. So you'll take that 26 factorial, count down to the 21 because that's what's in our denominator. 21 factorials will cancel, leaving you with 26, 25, 24, 23, 22. Multiply those together, that'll give you 7,893,600. Any questions? Any questions? All right, so 11.2, remember the title of 11.2 is permutations. So there is a formula for calculating permutations. So we're talking about the permutation of n things, taking r at a time. So what we mean by that is that let's say if I have my class of 30 students and I want to know how many different ways could I choose 5 out of the 30. So we're talking about permutation of 30 students taking 5 at a time. So n is always your larger number. And so you notice, so here's the formula. We have n factorial over n minus r factorial. So if you want to know the permutation of taking n things r at a time, it's n factorial over n minus r factorial. Now we're going to go through the mechanics of how the formula works. But if you have a scientific calculator, you should have the permutation and the combination option in there. And you can use it. I'm not taking that away from you. Or you can actually go to a website and Google permutation combination calculator, and a bunch of free stuff out there that will do the same thing for you. Just need to establish what is n and what is r. All right. So first problem under this formula, we're looking at you and 19 friends have decided to form a consulting firm. The group needs 3 officers. We have a CEO, operating manager, and a treasurer. In how many ways can those offices be filled? Give you a chance to write it down for those who are writing. All right, so you and 19 friends have decided to form a consulting firm. We need 3 officers. How many ways can those offices be filled? So n is going to be 24. So make sure you're careful with that. Don't get locked in on the 19, but because we say you and 19 friends, so that would be 20 altogether. And then we have 3 officers. So R would be 3. So remember, I always said that the n is the larger number. So we have 20 factorial over 20 minus 3 factorial. Do the parentheses, 20 minus 3 is 17. And if you want to simplify, take your 20 down to 17 because the 17 is in your denominator, 17 factorial. So 17 factorial cancels out, leaving you with 20 times 19 times 18, and that would be 6840. So 6,840 different ways you can fill the offices. All right, any questions before we go to the next one? All right. So you're working for a TV network. Your assignment is to set the schedule for Monday evenings between 7 p.m. and 10 p.m. You need to schedule a show in each of the 6 30-minute time blocks. You can select from among 13 comedies how many different schedules can be arranged. So give you a second or a couple minutes to write that down for those who are writing. All right, so working for a network, you want to set the schedule for Monday evenings from 7 to 10 p.m. That's 3 hours. And you have 30-minute time slots during that 3 hours. So there's going to be 6 different 30-minute time slots. And you can select from 13 comedies. Now, in the example, they actually listed out 13 comedies and you had to count it out. But I wasn't going to write, all those titles down. But yeah, so just different ways of giving you the information. So you have 13 to choose from. So that means N is going to be 13, and you want to choose 6 out of the 13. If I can get it out of the 13. So 6 is going to be R. And you put it in the formula 13 factorial over 13 minus 6 factorial will ultimately give you 1,235,520. All right. Everybody good before we look at this last thing out of this section? All right. Permutation of duplicate items. So we have n factorial over p factorial times q factorial times r factorial and so on. So, and you can continue that as long as you have repeated items. So n is the total number of items. I guess I can put total up there. So total number of items, p represents the p items are identical. Q is q items are identical. R is r items are identical. And it'll make more sense once we put numbers on it. All right. Everybody good? Can we scroll up? Okay, and how many distinct ways can the letters of the word Mississippi be arranged? All right. So I'm going to tally up total number of letters. In this case, there are 11, so that's why N is 11. 11 letters in Mississippi. And then I is being repeated 4 times, S is being repeated 4 times, and P is being repeated twice. All right, and you can keep that going as long as you have repeated values. So we have 11 factorial over 4 factorial times 4 factorial times 2 factorial. And throw that in the calculator. And if you do so, make sure you use parentheses. So I tried to signify that here. Putting parentheses around whatever's in your denominator. So you have 11 factorial divided by, you know, everything that's in the denominator. And you should get 34,650. So with all of these things, make sure you know how to use your calculator if you're going to be using it. And if you have any questions on anything, make sure you get with me so I can help you out. Questions, any questions? All right, are we good? Can we go to the next page? All right. So now we're looking at combinations. So I mentioned before how combinations and permutations are similar. It's that permutations, and this is the main difference between the two. Permutations, the order matters. Combinations, the order does not matter. So just like we had a formula for permutations, we have a formula of combinations, formula for combinations of n things taken r at a time. So we have n factorial over n minus r factorial with an extra r factorial right here. So it's very similar to the last formula, it's just that we have an extra r factorial there in the denominator. Once again, n is always going to be the larger number. Are you ready to scroll up? Okay, so we have a 3-person committee is needed to study ways of improving public transportation. How many committees can be formed from the 8 people on the board? All right. So we have a 3-person committee. So notice the difference in the wording in this one versus the one we had in the last section. Last section where we were trying to form a consulting firm, we had specific positions, CEO, operating manager, treasurer. Here we just have a committee and it doesn't matter who holds what position, nobody's first or second or anything like that. So just a 3-person committee, everybody's on the same level. So we have 8 people on the board. So out of the 8 people, we're trying to choose 3. So remember, n is always your larger number. And we're choosing 3 out of the 8. How many different ways can we choose 3 out of the 8? And so once again, just walking us through the mechanics of it. But if you have a scientific calculator, there should be a combination function there that you can just put in 8 and 3 and get 56. But what we did here, 8 factorial over 8 minus 3 factorial times 3 factorial. You do the 8 minus 3 first, which will give you 5. Then from there, you count down 8 factorial down to 5, so that'll cancel. Then we expand to 3 factorial, 3 times 2. So like I said, this cancels. That's why I got a green slash here. And then 3 times 2 is 6, so they cancel. And that leaves us with just 8 times 7, which is 56. All right, questions before we go to the next one? All right. So in poker, a person is dealt 5 cards from a standard 52 card deck. How many different 5-card poker hands are possible? All right. So choosing 5 out of the 52. So N is going to be 52, R will be 5. So 52C5 will be 2,598,960. Questions? Any questions? Make sure we're okay. All right. So I think this is the last one. So 11.3 was short. So it says in January 2017, the US Senate consisted of 46 Democrats, 52 Republicans, and 2 independents. How many distinct 5-person committees can be formed if each committee must have 2 Democrats and 3 Republicans? All right, so once again, we have 46 Democrats, 52 Republicans, 2 independents that's a part of the Senate. We want to create a 5-person committee that has 2 Democrats, 3 Republicans. So looking at the Democrats first, these 2 Democrats can only come out of the 46 Democrats that we have. They're not coming from the Republicans or the independents. So I will calculate how many Democrats I have to choose from by doing 46C2. And that gives me 1,035. So it's 1,035 different ways I can choose 2 Democrats out of the 46. Then the 3 Republicans are coming out of the 52 Republicans that are available to us. So we do 52C3, and that 22,100 represents how many different ways I could choose 3 Republicans out of the 52 that we have. Now going back to 11.1, the fundamental accounting principle, tells us to multiply these two numbers together. And we'll get our final answer of 22,873,000. I said billion, 22,873,500 different ways to choose 2 Democrats and 3 Republicans. All right, questions. Okay, so that's all the new material we're going to cover for today. I know that some questions may not come up or may not even be generated till you actually get in there and try to do some of this work. So try the stuff out, see if you have any questions, and feel free to bring them to class. Your questions may help somebody else. So that door and that opportunity is always available to you. Before we close out today, any questions? Everybody good? Everybody straight? So we've done up to 11.3. We got 3 more sections in chapter 11 to cover, and then we'll talk about how we're going to move forward. But is everybody okay? All right. Well, if you guys are good, I'm good. Have a great day. Be safe. Have a great weekend. And I'll see you next week. Take care.